Hello students, so welcome to the class of classification and periodicity of elements. So today we will do the theory part 1. So we will cover the theory part only for today. So let us start our class. So I hope you are getting my classes till now. So disclaimer, the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@itk.ac.in and we shall remove the images. So what are the topics that we are going to cover today? So we will cover three topics. We'll first of all see modern law and present form of periodic table. Then we will see classification of elements. एंड एट लास्ट विल सी द पीरियोडिक ट्रेंड्स इन द प्रॉपर्टीज. तो बेसिकली आज जो हमारा क्लास होगा वो सबसे पहले हम समझेंगे कि मॉडर्न पीरियोडिक लॉ क्या है, मतलब जो करंट फॉर्म ऑफ लॉ एंड फॉर्म ऑफ पीरियोडिक टेबल है उसका बेसिस क्या है. नेक्स्ट जो चीज़ हम देखेंगे वो हम देखेंगे क्लासिफिकेशन देखेंगे एलिमेंट्स का डिफरेंट डिफरेंट ब्लॉक्स में. और तीसरी चीज़ हम देखेंगे वो पीरियोडिक ट्रेंड्स देखेंगे. तो कुछ कुछ ट्रेंड्स को आज हम स्टडी करेंगे, बाकी सारे जो ट्रेंड्स है वो कल स्टडी होंगे. ठीक है, जिसमें हमारा एटॉमिक रेडियस और आयनिक रेडियस वगैरह वगैरह ये सारी चीज़ें आज रहेंगी. तो सबसे पहले देखते हैं मॉडर्न पीरियोडिक लॉ. तो जो हमारा मॉडर्न पीरियोडिक लॉ है वो सबसे फंडामेंटल प्रॉपर्टी पर डिपेंड करता है, जो कि हमारा एटॉमिक नंबर. ठीक है. सो बेसिकली इट वाज सेड दैट अर्लियर इट वाज सेड दैट योर properties and chemical properties of the element are basically the functions of atomic mass. ठीक है. Okay, so the further on Henry Moseley he formulated this law and said that okay, your atomic number will be the one which is more important than your atomic mass, because atomic number क्या होता है हमारा नंबर ऑफ प्रोटॉन होता है, और जितना नंबर ऑफ प्रोटॉन होता है उतना ही इलेक्ट्रॉन होता है, और इलेक्ट्रॉन का ही डिस्ट्रीब्यूशन और ट्रांसफर या फिर एक्सेप्टेंस ही क्या करता है, रिएक्टिविटी को प्राइमरली डिसाइड करता है. ठीक है. तो हम कह सकते हैं कि the modern periodic law is stated as the physical and chemical properties of the elements are the periodic function of their atomic number. Okay, periodic function किसका है, atomic number का है ना. इस मॉडर्न पीरियोडिक लॉ को हम बोर पीरियोडिक टेबल भी कहते हैं, और इस चीज को हम अफवाह प्रिंसिपल के हेल्प से भी रिप्रेजेंट कर सकते हैं. तो जैसा मैंने बताया कि हमारे जितने भी केमिकल और फिजिकल प्रॉपर्टीज है उनको हम क्या करते हैं, बेसिकली उनको हम एज ए फंक्शन ऑफ एटॉमिक नंबर प्लॉट करते हैं. ठीक है. तो बेसिकली हम क्या करेंगे, अपने सारे जो एलिमेंट्स है उनको इंक्रीजिंग ऑर्डर ऑफ एटॉमिक नंबर में सजाते हैं, जिससे हमारा जो मॉडर्न फॉर्म ऑफ प्रोडक्ट टेबल है वो हमें मिला है. सो इन दिस टेबल व्हाट वी डू, एलिमेंट्स आर अरेंज्ड in increasing order of atomic number, so it is represented by Z, and the isotopes they are grouped together. अब देखो यहाँ पे आपको पता है कि आइसोटोप्स क्या होते हैं, जिनका एटॉमिक नंबर सेम हो और एटॉमिक मास क्या हो, डिफरेंट हो, उनको हम आइसोटोप्स कहते हैं. अब आइसोटोप्स के एटॉमिक नंबर सेम है, मतलब अगर उनके पोजीशन की बात करें हम प्रोडक्ट टेबल में तो वो भी क्या होगा, सेम होगा, क्योंकि हम एटॉमिक नंबर के अकॉर्डिंग क्या कर रहे हैं, पुट कर रहे हैं चीजों को. अब जिनका एटॉमिक नंबर सेम है उनकी केमिकल प्रॉपर्टीज और फिजिकल प्रॉपर्टीज भी क्या होगी, सेम होगी. सो वी कैन से दैट isotopes will have the almost say physical and chemical properties which will show resemblance with the other one, right? So suppose you are taking deuterium, you are taking tritium, or you are taking the hydrogen that is having one mass number. So all of these three are isotopes, so they will all occupy the same position as hydrogen. Similarly chlorine के भी दो isotopes होते हैं तो उनका भी पोजीशन क्या होगा, सेम होगा. अगर हम टेबल की बात करें तो इस टेबल में टोटल 7 पीरियड्स होते हैं और 18 ग्रुप्स होते हैं, है ना. 7 पीरियड्स होते हैं और 18 ग्रुप्स होते हैं. और पहले क्या था कि हमने इन्हें ए और बी ग्रुप में डिवाइड कर रखा था, विच वाज आवर प्रीवियस कन्वेंशन, बट लेटर ऑन वी हैव गिवन द नंबर फ्रॉम 1 to 8 simply, right? And the zero group has been changed to 18. So let us see this with the help of the table. So this is our table. So see, this was the previous convention. So we have 1A, 2A, 3A, 4A, 5A, 6A, and 7A. Then we have the eighth one of all these three columns. Then we have the 1B, 2B, 3B, 4B, 5B, 6B, 7B, and 0. Okay, so this was the previous convention. अब जो कन्वेंशन है वो नया कन्वेंशन क्या है कि हम सिंपल काउंट करते हैं 1 2 3 4 5 6 मूविंग ऑन टू द 18. तो चेंजेस क्या हुए, 7 के बाद हमने सीधा 8 9 10 नॉर्मली कर दिया, और जिसे हमने जीरो ग्रुप दे रखा था वो हमारा क्या हो गया, 18th ग्रुप हो गया। ठीक है, तो टोटल नंबर ऑफ ग्रुप्स कितने हो गए आप क्लियरली देख सकते हो कि 18th ग्रुप है। अगर आप पीरियड काउंट करेंगे तो कितने पीरियड्स हो रहे हैं, सो इट इज बेसिकली 1 to 7। ठीक है, तो यही हमारा क्या है, the modern form of the product table or the long form of the product table that you see in your day to day life, right? So अब यहाँ पे देखो, अगर atomic number mentioned है देखो, so we are starting from 1 2 3 4 5 6। so what are we doing, we are arranging the elements in the terms of their atomic number। ठीक है, यहाँ पे हम किसको प्रायोरिटी दे रहे हैं, एटॉमिक नंबर पे, क्योंकि हाइड्रोजन का एटॉमिक नंबर 1 है, उसने हमें फर्स्ट पोजीशन पे प्लेस किया। फिर हमारा हीलियम है, फिर लिथियम, बेरिलियम, बोरॉन, कार्बन, नाइट्रोजन, ऑक्सीजन। अब यहाँ पे एक एनोमली है, द प्रॉब्लम इज दैट योर हाइड्रोजन is placed in the metal series and it shows property of the non-metals also. Okay, so basically why is the periodic table first of all formulated, so it is being formulated to study the chemical and physical properties in a convenient way, right? So if you are saying that okay, we have 118 elements and you want to study them all individually, then that would be very difficult. So what we have done, we have made groups of them, so that okay, we will say that this group will have the same properties and this group will have the same properties. So if you know the properties of one of the element, then you can predict the properties of rest of the element that is present in the same group. So that was the main motive behind this periodic table. But the problem here is that the hydrogen which is in the first group, it does not have its similarities with the properties of the other elements that are present, that is your lithium, sodium, potassium, rubidium, cesium and francium. And if you want to put it in the non-metal side, then also the problem arises that it doesn't have a noble Gauss configuration. Neither it can fit to the halogen because it is not that much electronegative. So due to that reason, your position of your hydrogen is contradictory, right? It is very difficult to place it in the periodic table, and it is still debatable, right? So this is our modern form periodic table. Now if you look at the bottom side, so अगर आप यहाँ पे देखोगे तो नीचे पे देखो, यहाँ पे दो जो प्रेजेंट है यहाँ पे सीरीज, that is starting from cerium to lutetium and from thorium to lawrencium. So all of these are what? So they are placed on the bottom down, okay, and they are called lanthanoids. So we'll study these groups individually right now. We will classify all our elements on the basis of their atomic configuration into different groups. Okay, so let us begin the classification. So depending upon the orbital in which the last electron enters. So just keep the track of all the words that we are seeing. So what are we seeing? We are seeing the orbital, means whether the s orbital or p orbital, in which the last electron enters, and the element are classified as follows. मतलब हम क्या कर रहे हैं, जहाँ पे हमारा लास्ट, जिस ऑर्बिटल में हमारा लास्ट इलेक्ट्रॉन घुस रहा है, उस उसी के अकॉर्डिंग हम क्या कर रहे हैं, उसका क्लासिफिकेशन कर रहे हैं। जैसे कि अगर मैं बात करूं तो हमारे पास एस ब्लॉक है और पी ब्लॉक है ना? तो इन एस ब्लॉक वी हैव दिस ग्रुप 1 alkali metal and this group 2 alkaline earth metals. Now in both of these elements, means the first two groups, the last electron is going to the s orbital, right? So this is the thing that differentiates each and every block elements. Okay, so you can see that what is the general configuration for them then. So it is ns1 to 2. Okay, so again I am repeating it, that your last electron is going to the s orbital and its general configuration is ns1 to 2. Then next one is the p block element. So what are the p block element? So the p block elements are those in which the last electron is going to the p orbital again. Okay, so it is starting from group 13 to group and ending to group 18, excluding helium, because it does not belong to this block. Okay, because helium is what? Helium is a element in which the last electron is going to the s orbital and not the p orbital, right? So you should remember this, that your helium is not in the p block. Now what will be the general electronic configuration? So it will be 1s2, no sorry, it will be ns2 and np1 to 6. Now why are we saying it as n and n? Because suppose you are saying that your element is in the p block and it is in the second period, right? So if it is in the second period, that means that your n value is 2. So here also it will be 2, right? So suppose you are saying that number of electrons in the p orbitals are 3. Then what will be the element? So it will be 1s2, then it will be 2s2, 2p3. Okay, so this is the thing. Here n signifies. Now we can collectively call this S block element and P block element as representative element or the main group element, right? So आपने ये बार बार सुना होगा मेन ग्रुप, ठीक है, बहुत बार आपने क्लास में भी सुना होगा। तो मेन ग्रुप एलिमेंट बेसिकली क्या होते हैं? मेन ग्रुप एलिमेंट बेसिकली एस ब्लॉक और पी ब्लॉक दोनों को कंस्टिट्यूट करते हैं, मतलब उनके लास्ट इलेक्ट्रॉन, मतलब जिन एलिमेंट्स के भी लास्ट इलेक्ट्रॉन एस ऑर्बिटल और पी ऑर्बिटल में जा रहे हो, उन्हें हम क्या बोल देते हैं? मेन ग्रुप एलिमेंट्स बोल देते हैं, है ना। नेक्स्ट नेक्स्ट हमारा है डायगोनल रिलेशनशिप। So as I have already told to you that our chemical and physical properties are nothing but uh, a periodic classification of the atomic number, and we are doing this classification so that this study of the physical and chemical properties can be made easier. So keeping that thing in mind, what we have done, we have seen upon this, we have to see upon this diagonal relationship. This is very very important from your exam point of view also, and for a chapter from your chapter point of view also. So this is basically the diagonal relationship. So according to this theory, we say that the first member of the S block and the P block. So what? Which member? The first members, right, of the S block and the P block shows different characteristics from the rest of members of the group, same group, right? So what is the meaning of this? So suppose what are the first three elements of the second period? It is lithium, beryllium, and boron. So second period is the one which constitute the first member of every S block, because in the first period we have hydrogen and helium, and they do not belong to the S and P block because their last electron is not going to the S and P block, and your hydrogen position is not signified, sorry, not determined till now. So we start from the second period. So we are saying that every element of the second period which is in the S block and P block, their properties do not मैच विद द रेस्ट ऑफ द एलिमेंट्स दैट आर प्रेजेंट इन द ग्रुप। जैसे कि अगर मैं लिथियम की बात करूं, तो इसकी प्रॉपर्टी सोडियम और पोटाशियम, सीजियम, फ्रांसियम, इन सब के साथ मैच नहीं करती। यही सेम चीज बेरिलियम के साथ है और यही सेम चीज बोरॉन के साथ। तो होता क्या है, इनकी प्रॉपर्टीज बेसिकली अपने जस्ट नीचे कंसेक्यूटिव वाले से मैच नहीं करके अगले वाले से मैच करती है, जो कि मैग्नीशियम। जैसे कि मान लो हमारा प्रोडक्ट टेबल ऐसे लिखा हुआ है, लिथियम मैग्नीशियम, लिथियम बेरिलियम बोरॉन कार्बन, फिर सोडियम मैग्नीशियम। तो इसकी प्रॉपर्टीज इससे मैच करनी चाहिए थी, पर इसके साथ मैच नहीं करके ये आपने डायगोनल वाले एलिमेंट के साथ मैच करती है। सिमिलरली इस वाले एलिमेंट की प्रॉपर्टी इस वाले एलिमेंट के साथ मैच करती है, और बोरॉन की प्रॉपर्टी सिलिकॉन के साथ मैच करती है। तो ये क्या हो रहा है, इन दोनों के प्रॉपर्टीज के बीच में एक सिमिलैरिटी हो रही है, और इसी सिमिलैरिटी को हमने क्या नाम दिया है? diagonal relationship. Okay, so what is the reason behind its diagonal relationship? So see, when you will move further in the chemistry, you will see that all of these properties are totally dependent upon the charge is to size ratio of the atoms. Okay, so basically these metals here, they have a very sorry, this not metals, I would say that this elements here, they have a very small atomic radii. Now their atomic radii is very small, due to which they show anomaly in this property. And as their say radius is small, but their charge is to radius ratio is almost same as this magnesium. Same goes this with this pair, and same goes with this pair. So basically, if you are asked that what is the reason behind this diagonal relationship, so our answer would be that your radius ratio of this diagonal elements are almost comparable, and hence they show similarity in the properties. Then we have the D block element or the transition element. So what are D block elements? So if you start from group 3 to and move to group 12, then all the elements that are falling in these groups are called as D block elements. Now two outermost shell D block elements are incomplete. What is the general configuration of this? It is n minus 1, D1 to D10, and ns 0 to 2. So see, you can see here that if you are talking about the 3D elements, then the s electron will be in the 2s. Okay, so this was the significance this n minus 1 and n is holding. Okay, so we have three series basically which are important to us. There are actually four series, but three series are most important, which are 3D, 4D, and 5D. Okay, now why these are called transition elements also? Because what we are doing here is we are transiting from the S block to the P block. So for that reason, we are calling them as the transition elements. At last, we have the inner transition element or the F block. So, so I will not define this electronic configuration again. So just keep it in mind that its electronic configuration is n minus 2 f1 to 14, n minus 1 d0 to 1, ns2, and their last electron obviously enters the f orbital. And there are two series, right? This is very, very important, that 4f and 5f. So if the last electron is going to the 4f, we call it the lanthanoid, and if it is going to the 5f, we call it as actinoid. So they call it as a 4f or 5f series also. Now they are also called as rare earth metal because there are very less specimen of these elements present, and all of them means almost all of them are laboratory prepared, means synthetically prepared and not naturally occurring. Now why do we call as inner transition? Because they are not in the transition element series, but they're inside the transition element series, and hence they're placed at the bottom. So they are kind of, you can think it as the penultimate one, ultimate one, penultimate one, and the super penultimate one, right? Okay, so moving further. So next thing is naming of the compound which have atomic number greater than 100. So before 100, we don't have any such naming criteria, but after 100 we have one to keep our things simple. Because after 100, what happened in the 20th century and the 21st, late 21st century, that at the same time, multiple researchers claimed that this element is found by them or invented by them. So they claimed the name. Okay. So to keep that hectic thing aside, what IUPAC did is they after 100 they assigned a nomenclature system to name each of these elements, right? So what was the basis of this element? So for every number we have a code. Okay, for one we have un, two we have bi, three we have tri, eight we have oct, and nine we have n. Okay, so this is the code. So everything has a code, and every code has a abbreviation at the same time. Okay, and these abbreviations are unique. Now suppose you have to name an element 101. So how you will name it? First one is there, so you will take un for one. Then you have zero, so nil for zero, and again we have un, sorry, one, so we will take un again, and at last you will put ium. Okay, this is the root word. So with this you complete your name. Suppose you have 121, then how you will name it? You will name it un, then by, then un, then ium at the last. So this is a very simple thing. Questions are asked from here, so I should suggest that please get through this. It will easily help you to score marks. Okay, now we'll move to the trends. Okay, so first we will discuss about the atomic radii. So what is the atomic radii? So it is basically the distance from the center of the nucleus to the outermost shell containing the electrons. Okay, so distance between the nucleus and the valence shell. Now if you move from left to right, the atomic size decreases. Why it decreases? Because the electrons are added to the last shell, and the last shell has more electrostatic force, and it is pulled inward, and for that reason if you move from left to right in a period, the size decreases. If you, on the other side, if you move from up to down, since the number of shell is increasing one by one, therefore the size is increasing. So this, they are opposite of each other. From left to right it will decrease, atomic radii will decrease. From up to down it will increase. Clear? Now it is referred to both covalent and metallic radii depending upon the element is a non-metal or metal. So if you are talking about say metal, then you say that we will consider metallic radii as the atomic radii, and if you are considering the non-metal, then your covalent radii is considered as the atomic radii. Now let us talk about the covalent radii. Suppose you are talking about the non-metal A. Sorry. So if you are talking about the element A, and suppose it exists as A2. Okay. So since to measure the distance of one atom is very difficult, so what we do is we take the whole molecule and we say measure the distance between the nuclei of these two atoms, and we divide it by 2. So we are taking it dA means the atomic distance between the two nuclei, and we're dividing it by 2, and we get the atomic radii. So this, both of these atoms are of the same molecule. Okay. Now when we are moving to a heteroatomic molecule like AB, then what we do, we take the electronegativity to help to calculate the things. Okay, suppose you are saying that dab is the distance between A and B nuclei, then in that case their relationship between them will be, it will be Ra plus Rb minus 0.09 chi A minus chi B, when chi A and chi B are the negativities of the A and B. So suppose if you know A, if you have calculated DAB, then you can easily calculate RB. So this is the utility of the formula that we have. Next we have the metallic radii in case of metal. So what we do simple is we take the metal cluster, know the distance between the two metal atoms, and we divide by 2, we get the metallic radii. And third is the van der Waal radii. So van der Waal radii is the so there is a difference between the covalent and the van der Waal radii. In the covalent radii, we measure the distance between the atoms nuclei which are the same molecule. But in covalent van der Waal radii, what we do, we take two different molecule and measure the minimum distance between the two nuclei. Okay, so that thing is called as van der Waal radii, and we divide it by 2 to get the thing. So there is a comparison between these three. So covalent radii is the shortest one. Then we have the metallic, and van der Waal is the longest because we are considering two different molecules. Clear? Okay. So further, then we have the ionic radii, which is for ions. And what it is? So it is the distance between the nucleus and the outermost shell for the ions. Now, cationic radii are always smaller than its neutral atom. What is the reason behind it? Because we are removing the electron in case of cation. So the same number of protons are there, but the electrons have decreased. So the electrostatic force will increase. Okay, because now suppose 10 people are pulling 10 people, then there will be an equal effort. Now suppose 10 people are pulling 7 people, then the 7 people group will be moved more towards the 10 people, and that will result in contraction. So same thing is happening here. You can take the same analogy, and whereas in case of your negatively charged, that is your Ni, the size will increase. Just opposite. So if your charge is decreasing, then your size will increase, and if your charge is decreasing, the size will increase. Clear? Okay. So 2 negative, the negative 2 charge, then we increase the charge, means not the magnitude but the actual value. So 2 negative, then negative, and neutral. So if you take positive one, then O positive would be here, and then the 2 positive will the smallest one. So this is the thing. So we can say that the ionic radii is directly proportional to the magnitude of nuclear charge. Okay. Next we have the ionization enthalpy. So what is ionization enthalpy? So it is basically the energy that is required to pull the electron from a gaseous atom. So remember these terms, this is the important term. So what we do is we first convert your given atom into the isolated gaseous atom, and then we abstract an electron, and the energy that is required to abstract the electron is termed as what? It is termed as your ionization energy. Now talking about the ionization energy, it increases from left to right because we are moving from left to right, then the atomic radius is decreasing and the electron is going more towards the nucleus, so we will require more energy to pull out the electron. Whereas if you move from up to down, then the energy will decrease because now the electron is moving away from the nucleus, and we will have to supply less energy to remove that electron. Clear? One more important thing, that if you are pulling electron from the half filled and a full filled, you will require more energy than the normal case, because half filled and full filled are more stable due to the number of exchange energies they have. We have studied this thing in the Hund's rule of maximum multiplicity, that half filled and full filled orbitals have an extra stability. Okay. Now various factors are there which changes this ionization energy. First is atomic size, second is screening effect, and third is nuclear charge. So let us talk about some points, facts we have. So helium has the highest ionization energy, and cesium has the lowest, because cesium is the largest one, and after removing one electron, it gets an noble gas configuration, whereas the helium is a noble gas and it's the smallest noble gas. Now ionization value of inert gas are exceptionally high due to the extra stability of the octet and also the complete filled orbital. Ionization energy of group 2 elements is greater than the corresponding elements of the group 13 due to the fully filled s orbital. Okay, so if you talk about group 13, so if you are pulling an electron from there, then it will have a higher stability due to the fully filled s orbital. Next, a very important point we have here. So basically it is seen that if your last electron is there, then it will feel an screening effect from the inner electrons. So what is the screening effect? Basically inner electrons, means the electron between the valence shell and the nucleus, they act as a shield, right? They restrict the overall effect of the electron on the overall effect of the proton on the electron, and hence it becomes easier than the ideal case to remove the electron. So that is called as shielding effect. So when you will move to higher classes, you will calculate the shielding effect in this way. So basically, suppose this is your actual Z. Okay, this is your actual Z, this one. Okay, now due to some shielding, there is a shielding constant that arises, which you can calculate using this formula. You can just look at it once. It is not that much important from exam point of view. And this is the Z effective that you calculate, the actual Z that you get. This is the ideal case one. And due to the shielding of the inner electrons, you subtract some of the Z and you get a Z effective. Okay. Okay, so last is electron gain enthalpy. So what is electron gain enthalpy? So it is the energy which is released when an electron is added to an isolated gaseous atom. So similar to your ionization energy, here also we are adding an electron. Where we are adding an electron to the gaseous atom. So in ionization energy, we are removing an electron from the gaseous atom. Here we are adding one. Okay, so if you talk about the value, then chlorine has the highest value because it has a larger size and a higher electronegativity. Now some of you will say that why not fluorine but chlorine? Because chlorine has the larger size, although it has a low electronegativity, but it has a larger size, whereas chlorine has very small size. So if you may enter electron into it, then it will cause repulsion, and hence this will give lower electron gain enthalpy. Now, opposite of ionization energy is the electron gain enthalpy. We have seen it. Now, if we talk about the factors, then the atomic size varies inversely, with the electron gain enthalpy varies directly to the nuclear charge. And if your configuration is already having a half filled or full filled orbital, then the electron gain enthalpy will be low because it is already stable. Now, fluorine and oxygen have a small size, due to which they have a lower electron gain enthalpy. I have discussed it. Electron gain enthalpy of elements group 2 and 15 is low because of their stable half-filled configuration. But for group 18 it is positive because of the complete shell, because the octet is complete. Okay, so this was for today's class. Thank you.